Push That Rock here with Simpson Math, discussing matrix multiplication. How do you multiply matrices together and what does it mean? Wreck 'em. So, we learned last time that a matrix, a 3 by 2 matrix, is a mapping from 2 space to 3 space. So, if you have a function and you're going to multiply it by another matrix, what does that mean? Last time we just had a vector here. Well, what it means is this matrix on the right is nothing more than a storage bin of domain elements. It's storing, holding domain elements of this function. That's what it's doing. So since this is a matrix that's 3 by 2, meaning it has 2 columns, remember the number of columns determines the domain. So the domain is R2, the regular old Cartesian plane, XY, So XY, so forth. Okay, so these are domain elements. And we're going to map these to what space? If you go from, if the 2 tells us the domain, what does this 3 tell us? The codomain. So we're trying to get 3 space vectors out of 2 space vectors. So we're going to map this 5, 6 to some 3 space vector. We're going to map this 0, -1 to some 3 space vector. And the same here and the same here. And how do you do it? Well, you just do it like we were doing before. It's nothing new. So, for instance, I'm going to take the 5, 6, and map it to a 3 space. And the way you do that is you go first entry times first column, like we did before. See, the 5 is the first entry in the input times the first column in the function, plus the second entry in the input times the second column in the function. So I quintuple everything here, 5, 10, 15. I sextuple everything here, 6, 6, 0. Then I add, so I get 11, 16, 15. Oh, so 5, 6 became 11. Oh, I can't write this way. 16 and 15. Can y'all even see that? Oh, yes, you can, barely. Okay, that's great. All right, what about the 0, -1? The 0, -1, what do you do with that? Well, you do the same thing. So we're going to take 0 times all of these guys and get nothing but zeros. We're going to take -1 by all these guys and just change their sign, then add, so we get -1, -1, 0. So we get -1, -1, 0. Okay, well, what about the 3, 9? What about the 3, 9? What happens there? Well, you take the 3 and triple everything in the first column, 3, 6, 9. You take the 9 and non-tuple everything in the second column because it's the second entry times second column. So 9, 9, 0. Then you add, so 3 and 9 is 12, and 6 and 9 is 15, and 9 and nothing is 9. So I get 12, 15, 9. So this next one is going to be 12, 15, that's terrible, and 9. We got one more to do. We have to transform this guy. How do you do it? Well, you're going to go 4 times this and -2 times this. I have it written out over here. We don't have to struggle mentally. So quadruple everything in the, since the first entry is 4, quadruple everything in the first column. So we get 4, 8, 12. And then we have -2 in the second entry. So we multiply that by the second column, get -2, -2, 0. Then 4 and -2 is 2, 8 and -2 is 6, and then 12 and 0 is 12. So we get -2 here, -2 here, and what was that last one, 12? And so this is the product. What is this? This is a storage bin of all the outputs. So we had a storage bin of inputs that belong to 2 space. This thing turns all of them into 3 space vectors, and now we have a storage bin holding all our outputs for us. Isn't that nice of it? Math made simple at Simpson Math.